An old beggar collects cigarette ends from ashtrays and sidewalks and uses the tobacco to roll her own cigarettes. She has this practice down to a fine art, knowing that 7 cigarette ends will make 1 cigarette. Since she has collected 49 ends, how many cigarettes can she make from these? There you go. Pause that and rewind if you want. Alright, finally, part 2, we've got 10 different tests. I think there's 10 in this packet, but anyway, it's close to that. Test number 1, basically, before we get going here, you're going to learn different tests. You can't use every single one of these tests on every single series, nor you don't want to. And I will teach you which ones are the most convenient, which ones you're going to try first. You can probably use on most of them. And basically, there's not just one rule. Okay, there's different tests based on the different kinds of functions that you're going to, or series that you're going to see. And it's your job to memorize all of these tests. I will give you tools to do that. But the more familiar you are with these tests, it's like the more familiar you are with multiplying, the easier it is to do all the math. Okay, so the easier it's going to be to determine convergence or divergence, and you just have to learn them. At first it's going to seem like a daunting task, but it really is not that bad. You have certain tests that you'll use most of the time, and you might get one problem in the entire AP exam in which you forget which test you're going to use. No big deal. Okay, so let's go ahead and dive right in. Alright, let's see here. Any notes? Any notes? No. The nth term test is the first test that we're going to try. In fact, this is the one I always want you to try first. Always try this one first. Okay? Okay, so 2 stars. That's great. Always try first. And the reason why you always try it first is because typically it's the easiest one, and you don't waste your time trying to show that a series is convergent when it obviously diverges. Okay, so a quick kind of a lesson here. You're going to take the limit of the nth term, and that's a pretty easy thing to do as n goes to infinity. So basically you're going to see, well, where are these terms going? So just to give you kind of a rationale, if the nth term is going to a number like, let's say it's not going to be 0, 1 plus 2 plus 3 plus 4 plus dot 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 plus n, okay, plus dot dot dot. Well, what's the limit of the nth term? Well, the nth term here is going to infinity. As n goes to infinity, you can see these numbers just keep getting bigger and bigger. Well, there's no way that series is going to converge. The numbers just keep getting bigger. So keep in mind the meaning of these tests, and when you understand the meaning, they make more sense. Instead of just trying to memorize a bunch of rules, try to seek meaning behind what you're doing. Okay? Think of this other one. And sometimes you see these. Oops, 1 plus 1 plus 1 plus 1 plus... Okay, what's the nth term going to? Is the nth term going to 0? No. The nth term is 1. In fact, every single term is 1. And if you add up an infinite number of 1s, the numbers are just going to keep getting bigger and bigger. The series will not converge. The series would diverge. Okay, so just keep in mind that the nth term needs to go to 0 for sure to converge, but just because it goes to 0 doesn't mean it converges. And remember, that series that I showed you before, 1 plus 1 half plus 1 third plus 1 fourth plus dot 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 plus 1 over n plus dot dot dot, what does that nth term go to? That nth term, as n goes to infinity, you better be able to say that that goes to 0. So the limit, you would say the limit as n goes to infinity of 1 over n, well, that's 0. Okay? Well, I already told you that this series diverges. And I told you that's a really important series to remember. Because it's a series that helps you remember that when the nth term goes to 0, it doesn't mean you know anything. In fact, you know nothing. If the limit, we can say if the limit as n goes to infinity of a sub n equals 0, we know nothing. Okay? You don't know anything yet. All you know is that the nth term goes to 0. It means we don't know anything about the convergence or divergence of the series. You need to make sure that you understand completely this series right here. Nth term goes to 0. It diverges. You could have an nth term going to 0 and it converges. But the nth, all that being said, if the nth term as n goes to infinity does not equal 0, or if that limit fails to exist, then we know that the series diverges. Okay, so that is one thing we can conclude using this nth term test, that the series diverges. Okay, so let's take a look at an example. Super important stuff. We take this series here, we look at the nth term, we take, okay, well the limit as n approaches infinity of n minus 1 over n plus 1, you should see clearly that that limit is 1. Okay, and you would say, therefore, this series, this guy right here, this is the series, diverges. Okay, so that's how you say it. If this is an FRQ, you would say, therefore, that series diverges. Okay, let's try another one. The limit as n approaches infinity of, here's our nth term. Okay, the nth term is always just that stuff right there with all the n's in it. 4n squared minus n cubed over 2n cubed plus n squared. I'll let you figure out what that limit is. You should know what that limit is. It's a rational function. We should just take the, you know how to do that. Take the biggest term in the numerator, or the one that grows the fastest in the numerator, one that grows the fastest in the denominator. The other terms are insignificant. So this term right here is a significant one. This term right here is significant. So you should say that the limit is negative 1/2. Well, guess what? That's not equal to 0. Oh, I should have said that up here. Equals 1, not equal to 0, therefore. So you have to acknowledge that what you get as a limit is not 0. Therefore, so that's what you can conclude. Therefore, the series diverges. And we say here that therefore, let's just say therefore diverges. Okay. All right, so there's test number 1. 9 more to go. Test number 2 is a pretty easy one because you've basically already done this. Here we have if it's a geometric series. This is one also most likely that would come up on an AP exam. It's an infinite geometric series, and you know that if that guy right there, if that common ratio has an absolute value of less than 1, then it converges. If it, meaning the absolute value of that common ratio, is greater than or equal to 1, then the series diverges. Well, that should make sense, because from the very beginning, when you learned infinite geometric series, you learned that it's only true, the sum is only this, when that r is between -1 and +1. And so sometimes they're hard to recognize that they're geometric series. And so if you have a hard time, here's what you need to do. Hope you're listening. 10 to the negative n, I'm going to write that as 1 over 10 to the n. And I'm also going to write that, I'm not going to rewrite the n equals 0 to infinity, as 1 over 10 to the n. Okay, whenever you see a number to the nth power, you know that what that's going to mean. And again, if you have 0 to infinity, if you have a hard time seeing the common ratio there, just write out the first couple terms. 1/10 to the 0 is 1, plus 1/10 to the 1 power is 1/10, plus 1/10 to the 2 is 1 over 100, or 1 over 10 squared, 1 over 10 cubed, plus dot dot dot. Hopefully you can see here the common ratio is that 1/10. You multiply each term by 1/10 to get to the next term. Well, this guy always being raised to the nth power, that's always your common ratio. Okay, and we can see that our common ratio, 1/10, is less than 1. I could say greater than -1 also. Okay, therefore converges. Therefore, our series converges. Okay? That's that. Let's see if we can get to the end of this first page before the video cuts off. Now, geometric series test could be an alternating series. Nth term test could be an alternating series. The first test in which all the terms have to be positive is this guy right here, the integral test. You're not even allowed to use the integral test if some of the terms are negative. So you always need to make sure you check that. It's not a test you're going to use very often, but it should be, once you learn it and do a few examples, it should be pretty obvious when you would use this particular test. Okay, so and also not only do all the terms have to be positive, but the terms also need to be decreasing in value. So I don't really have a good example for you here other than, let me just tell you the test and then maybe I can find an example for you somewhere. Basically, if you take the f of n, so you take the nth term and convert it to a function, okay, if back in chapter 8 you learned how to find these improper integrals from 1 to infinity of f of x. If the integral of f of x is convergent, then the series with that same, instead of f of x, it's going to be a sub n. So a sub n is, let me give you an example. So let's say a sub n is 1 over n squared. Okay, so if a sub n, this is what I'll do, if a sub n is 1 over n squared, then f of x would be 1 over x squared. Okay, and so you would say that since the integral from 1 to infinity of 1 over x squared dx converges, then the series from, let's say, n equals 0 to, or 1 to infinity of 1 over n squared also converges. Well, converges. Okay, so if you start with this series 1 over n squared and you want to know if it converges, well, you can see that all the terms are going to be positive. See, 1 over n squared, so you have 1 over 1 squared, 1 over 2 squared plus 1/4, 1 over 3 squared plus 1/9, and so forth. The terms are getting smaller and all the terms are positive. That's what you have to have in order to use the integral test. Okay, and so if you want to show that this particular series converges, you could do it using the integral test. There is a better test later on. It's just one kind of popped in my head here. But you would relate this to 1 over x squared, and the integral of 1 to infinity of 1 over x squared dx does converge, and so therefore the series also converges. Okay, and so it also works with if the integral from 1 to infinity of f of x is divergent, then the series is also divergent, so they go hand in hand. So there's your integral test, and sorry I didn't have a good example for you, but I will try to find one for you guys to do in class on that one.